Here I'm going to look at 3 examples dealing with the areas of regular polygons. And the first one, give you a hexagon, and I'm telling you that it's regular. Notice that in the directions. And we want to find the area of it. So the first thing I do is I think back to, well, how do I find the area of a regular polygon? Well, it was area equals 1/2 times the length of the apothem times the perimeter. And now I look at my picture and I go, well, the apothem, it gives it to me. So I'm just going to plug that right into my formula. The apothem is going to be 5√3. My perimeter, well, that I'm going to have to do a little bit of work, not a lot. I know that a side length is 10. So I can take 10, and being this is a hexagon, there's 6 sides, so then my perimeter is going to be 60, and then multiply it by 1/2. Now this is something that I don't think I'm going to need a calculator for, because I can do a little bit of this in my head, or I can do all of it in my head. I'd have that 10 times 6, that's going to give me 60, but 60 times 1/2 is going to be 30, and then 30 times 5 would be 150, and times √3 would be 150. √3 is the area of my regular hexagon, and then make sure that I put my label on there, which would be square inches. Now, if you want an approximation for that, it's just a matter of typing it on your calculator. So you take 150 times √3, and you end up with 259.81. It's the approximate 259.81 square inches. And you have the area of your regular hexagon. Now my next one, some people get a little worried because it's a word problem, but don't let it scare you too much. Just look at the information that's in there. It wants us to calculate the length of the apothem of a regular dodecagon if the area is 716.64 square centimeters, and we know that the sides are 8 centimeters long. Well, the first thing that I look at here is it talks about area of a regular polygon. Again, I'm going back to area equals 1/2 times the apothem times the perimeter. And I'm going to start looking at things to plug into this formula to see if maybe if I plug a bunch of things in, I'll be able to solve for something that's missing. I look here and I see the area is 716.64. I'm going to put that in for my area. So I have area equal to 1/2. Now the apothem, it wants me to calculate the apothem, so that I don't know. I'm just going to leave that as the variable. And then the P for perimeter, well, I do know that the sides are 8 centimeters long, and I know that it's a dodecagon. Well, dodecagon is a 12-sided polygon, so I can get my perimeter by doing 12 times 8. Now I look at my little equation and, voila, there's only one variable. I can solve this. This side's not going to change for the time being. Equal to, well, I'm going to do the 1/2 times 12 times 8. And 1/2 times 12, that's going to be 6, and 6 times 8 would be 48. So 48a. And then divide both sides by 48. And we'll have it. We find out that A is equal to 14.93. Then we got to make sure that we get the right label. Notice that my area was centimeters squared, length of the sides was centimeters. Therefore, the length of the apothem is going to be 14.93 centimeters. And we're done with that one. And my last example, I want to find the area of a regular heptagon, and it gives me side lengths of 9 centimeters. Well, again, I'd come back to my area equals 1/2 times the apothem times the perimeter. Now this one you're going to look at and go, we have some problems, because the only thing that we know is the side lengths are 9, which is going to help us with the perimeter. We don't know the length of the apothem, and we don't know the area. So an equation with 2 variables is not good. But what I'm going to do is I'm going to try to draw this. It's a heptagon, so bear with me. 7 sides, 1, 2, 3, 4, 5, 6, 7. And I know it doesn't look really regular, but we just know in our heads that it is regular. And then what I'm going to do is I'm going to draw in my apothem, because I need to know that. If I can calculate the length of that apothem, I'm going to be able to figure this problem out. What I do know is that the side lengths are 9. So I'm going to put a little 9 here to help remind me. Now, that apothem there is going to cut each side in half. And the reason for that is because if I were to go here and draw in all these triangles like I did on the lesson portion that go back to each vertex, all of these triangles are isosceles. And when you put the height into an isosceles triangle, it cuts that isosceles triangle in half. Therefore, I know this part right here is 4.5. Now, the next thing I'm going to do is I'm going to calculate the measure of one of these angles. Specifically, we'll go with that one. And what I know is all those triangles in that heptagon are congruent, therefore all those angles around the center are going to be congruent, and then I can find the measure of just one of them. So if I take 360 and divide it by 7, I'm going to have the measure of each one of those angles I have marked with the orange arc. Now I end up with 51 point, I'm going to go 43. 51.43 degrees. Now the next thing I'm going to do is I want to find the measure of just this angle here. Because I noticed that this triangle, and maybe I should highlight it so it's a little bit easier to see. This triangle right here is a right triangle, where after I get the measure of that purple angle, I'm going to know one of the acute angles in the triangle, one of the sides, and then I'll be able to use trig to find the other missing sides. So to do this, I'm going to take what I had in the last one, the 51.43 degrees, and remember, the green apothem is going to cut that 51.43 degree angle in half. So now what I'm doing on my calculator is I'm not typing in 51.43. I'm using everything that was on my calculator, 51.42857,143, and there's probably more that's just not showing. And I'm just going to hit divide by 2 on that. I'm going to keep this answer as long as I can. So this is approximately 25.71 degrees. So that is the measure of this angle. And now I can use, like I said earlier, I can use trig to find the length of my apothem, that green piece. Because I look at this and I go, from my angle, the 25.71 degree angle, I know the opposite side, and I'm looking for the adjacent side. Well, that tells me I need tangent. So I'm going to use tangent of my 25.71 degree angle. The tangent is opposite, which is 4.5, over the adjacent side. I'm going to call it A for the apothem. So that's what I need to calculate to get the area of my regular polygon. So now I have my proportion. I can make this, put this all over 1, and now cross multiply. If I go this way, I'm going to get 4.5 equal to, and when I go this way, I'm going to have A times the tangent of 25.71. Now all I need to do is divide both sides by the tangent, 25.71, tangent 25.71, and I'll have it. Now again, I'm not going to type in 4.5 divided by tangent 25.71. Rather, what I'm going to do is I'm going to type in 4.5 divided by, then I'm going to push tangent, and then I'm going to use my calculator, and I'm going to go up, and I'm going to get my last answer. So by doing this, I end up with an apothem that's going to be approximately 9.34 units long. And those units in this case would be centimeters. So what I've done is I haven't rounded anything until now I'm at the very end and I got that 9.34. Now I'm going to go back, now that I have my apothem, I can go back to my area formula of a regular polygon, 1/2 times the apothem, which I just calculated, at 9.34, and I still have that number on my calculator. It's not going anywhere because I'm going to need to use that. And then I need to multiply by the perimeter. Well, each side was 9. So So 9 times their 7 sides, and I'll have it. Now it's just a matter of punching this all in my calculator. Right now the 9.344346285 is on my calculator. I'm just going to push times 9 times 7 and then divide by 2 for the times 1/2. And I end up with an area that is approximately equal to 294.35, and my label would be centimeters squared. So yes, that problem is a little bit in depth, but it's involving a lot of things that we've learned in the past. Just put all those little pieces together, and you're going to be able to find the area of any regular polygon using the techniques that I just did here. So just to kind of review, what I did first was I found the measure of one of those little angles, but then I have to cut it in half to find the measure of one of the little angles in the right triangle. And once you do that, then you can use trig to find whatever piece you need. Sometimes you may need the apothem, sometimes you may need to find this one, but you can use trig to find it. And then from there, once you have all the pieces, plug it back into your area formula for a regular polygon, and you'll have it. And that's where I'm going to conclude my lesson on, or not my lesson, but my examples on regular areas of regular